Ladies and gentlemen, welcome back to Let's Dev, where today we're taking a break from our current projects to work on a tiny experiment. Now, thanks to a recent video I saw, I learned of a board game called Gobblet Gobblers. It's essentially tic-tac-toe, but taken to the next level. And so I want to attempt to remake this game, but obviously in video game form. So the plan will be to take the concept of Gobblet Gobblers and translate it into a video game. I've also never made a tic-tac-toe game before, so this is going to be a learning experience. And so to start, we'll be focusing primarily on the basic functionality of the mechanics behind Gobblet Gobblers. Sounds like a plan, so let's get to the coding. I've already set up our game board before starting to record, and in fact, before we get to the coding, let's go over just how Gobblet Gobblers is played. Again, the game plays the exact same way as tic-tac-toe. Get 3 marks in a row and you win. However, Gobblet Gobblers takes this a step further by adding 3 tiers to the marks, meaning that a player can override their opponent's marker as long as they play a higher tier. So before we can run, we need to walk, which means creating the tic-tac-toe portion of the game. A 9x9 grid was created and filled with zeros per cell to mark them as empty. Then a left-click check was made, and if on the grid, the nearest cell to the mouse's position would be marked for player 1. Finally, temporary colored squares would be drawn for each marker placed on the board. And so far so good. Each cell in our grid was now able to be filled with player 1's marks, just as expected. So back in the code, a grid check function was created, then came the tedious attempt to check for matching marks. I began with a single column starting from the top left going down and checking specifically for each cell in the process. Then if the same column of cells had a sum of more than 0, that meant that they were all marked, which then initiated the previous check. This thankfully ended up working just as needed. When attempting to place the third mark, the game would reset, meaning our checks were in fact working flawlessly. And so with that working, it was back to the code. The check code was then applied to a loop that would then go through all 3 columns of our grid. And to make sure it worked for both players, a right click would do the same as the left click, only for player 2. And again, thankfully this ended up working flawlessly. Each vertical column was now being checked for matches anytime a marker is added to the board, and it would only reset if all 3 spaces share the same player's marks. So with that working, it was back to the code to duplicate the checks, but apply them to the horizontal rows of our grid. And surprise surprise, it worked just fine, so next it was time to figure out how to do the more complicated diagonal checks. Unlike the loop, a manual sum check needed to be done, and if those cells aren't empty, the same check made in the loops was then applied. Only again, done manually. Then the same was applied for the opposite diagonal direction, which again, thankfully, ended up working flawlessly. How I've managed to not break anything this far into the session, I will never know. But regardless of my disbelief, win conditions now existed for the game. So the code was then restructured with checks only being made when necessary. Next up, so the game wouldn't immediately reset on a win function was created. When triggered, this function would remove player control, start a countdown, and reset the game once the countdown hit 0. Then, because I wasn't sure how to approach it, another sum check was made in the grid check function, and if the total amount of the board exceeded a number large enough to suggest a stalemate, the check would then loop through the cells, and if all cells were in fact marked, the game would call it a draw, which was then reflected in the end game event where some hard-to-read temporary text would display the winner, or lack thereof, before restarting the game. And though I wasn't confident in the stalemate code, it seemed to work just fine, which meant our construction of a simple tic-tac-toe game was a success. But again, this is based on Gobblet Gobblers, so we weren't done just yet. Back in the code, a new DS grid was created and also filled with zeros in each cell. A marker size variable was also added, and in the left-click check, a size comparison was made. If the current size is larger than the size recorded in the target cell, then the marker is placed and the size becomes the cell's new size to beat. The size grid data was then changed from a single value to an array to also keep track of the owner of said marks. Then owner checks were added alongside the size check. And finally, the entire process of updating the grids was wrapped up in a single easy-to-use function. And holy moly, I don't know how, but the code actually worked. And worked well. Gobblet Gobblers was officially recreated in GameMaker, and somehow I did not mess up a single thing in the process. Well, no, sadly that's a lie. Unfortunately, the stalemate check wasn't perfect and would sometimes fail to trigger. However, I have already identified the issue and will be fixing it next time. Because yes, I expected the worst going into this one, having never attempted a tic-tac-toe game before. However, things going far smoother than anticipated leaves me very confident we'll be able to wrap this one up with one more episode, which will also be when we add our actual graphics to the markers instead of using boxes, as well as a few other potential bells and whistles. But that's for next time. For now, this brings us to the end of today's episode of Let's Dev. So remember to leave a like if you enjoyed the episode, subscribe and turn on notifications if you haven't already, and be sure to leave your thoughts on our progress in the comments. Thank you so much for watching, and I'll see you guys next time.